time again. Hi and welcome to yet another lecture. This time we are going to continue on Dart, the programming language, but this time we are going to look at the object-oriented parts of the Dart programming language. And Dart is object-oriented. It can be used in a non-object-oriented way as well, but it does use object orientation as a first-class citizen. We will in this lecture assume knowledge about basic object orientation, but point out in a few places where there's more to know. Just as the first lecture was a crash course in the foundations of Dart programming, this will also really be a crash course focusing on how to use object orientation in Dart. You will not need a complete understanding of how object orientation works to use Flutter, but it does help in understanding why things look the way they do if you have this knowledge. With that, if you feel that your knowledge on object orientation is not up to scratch, then we can recommend a few links, Geeks for Geeks and Educative, for example, and I also enjoy Derek Bana's YouTube channel for object orientation. And if you are into another programming language, you can probably just search for object orientation plus your favorite programming language. So with that, try to understand the essence of object orientation and then go on with this. And if you already know, just move on. So first off, using classes. So object orientation is about classes and objects, where classes can be seen as a template for something in the system and objects are the specific instances of that template. So for example, if we have the class car, then my specific Volvo V60 cross-country D3 could be the specific object in question. And Dart has many predefined classes, and Flutter has even more. It has loads. It's basically consists of a number of classes which are seen as widgets then in Flutter. But they are classes. We've also seen this list, for example, when we looked at the previous lecture. And in this case, we are going to look a little bit at random. So we need to import .math first. And then in our main, we create an object by saying that the name of the object should be RND, and it should be of type random, which is a class, and it should be created as an object from new random, so random class. And it's a call to the constructor of random. When that is done, we can use the object via dot notation. So to get the random number into the variable random number, we call the object RND and then dot next int 10, and it will give us a random number between 0 and 9, which we print out, as you can see over there. All right. As we've previously mentioned, the keyword new is something that they've decided to remove from Dart. It's still there, it's still possible to use, but you don't have to. When it is perfectly clear what it is you're going to do, namely to instantiate an object, you can do it as you can see in the code snippet over here. You can say random RND is assigned random parentheses, which is again the call to the constructor. So without the new, and that is the preferred way to do it. And the reason for this is that it makes Flutter code much easier to read. Before we had this removal of the new keyword, there were a lot of new that you saw everywhere, but you should not put new in anymore. It is, of course, possible to create your own classes, and you do that with the keyword class. And any fields or attributes then will be listed as in the example just beneath the name. So string name, string species, like we can see in the example then, where you could also see that name is a nullable. It could be null, so therefore a question mark. We can have a number of constructors defined. In this case, we have one called character, because a constructor always has the same name as the class. And in this case, it takes two parameters, the two strings called n and s, and we just use those values to set it. Describe in this case is something that returns basically a toString, returns a description of this character, this object that we instantiate later on. All right. And as name is nullable, this means that we need to have this exclamation point in order to say that this variable can be null when we print it out. In other programming languages, we usually declare our attributes or the fields as private. So they should only be accessible in the objects where they belong. It's part of encapsulation in programming. But in the previous example, they weren't. They were public, so anyone could access them anywhere. In Dart, we don't have a special keyword to say that a string, for example, is private. No, we use the underscore sign as the first letter of the variable name. And this is something that we've seen as common practice in other programming languages, but in Dart it is for real the way to create private variables. However, Dart uses something called library scope and not class scope, and this means that as long as the stuff is in one of the same file, then everything can access it, which makes it really important for you to actually create classes as separate files. So you should always do that. So we look at this updated class. It should be saved as a separate file. In contrast to Java, for example, it doesn't have to be named character. So it can be called anything, but it should be in its own separate file. And as you can see, we have here added an underscore for name and species in order to make those attributes private in this class. The way to change these private attributes is to use mutator methods, get and set. And in Dart, we have the keywords get and set to help us do that. And they should then have the same name minus the underscore as the attribute they are working with. This makes it fairly easy to create getters and setters for the different attributes that you have. And this helps in encapsulation, in making sure that the object isn't treated in a wrong way. When we are using these mutator methods, we will use them as if they were direct access, but they are not. They are actually going through these mutator methods. So even though when we look at the example over here, and we can look at the code to the right first, even though we first create the Coruscant planet with 3 moons, and then we set the number of moons to 4 via corresponding.number of moons assigned 4. It's not directly accessing the attribute. It is, however, going through the set method. So if we look to the left, we can see that we have a method called number of moons or num of moons, which has the keyword set in front of it. And then it works exactly the same as any other method. And since the get version, which you can see below that, just returns a value, we use the arrow function instead. So the arrow and then just the value that we want to return. We've already mentioned that we have constructors, but there are some specifics we can do with them. So for example, if we don't want to check the values for any one reason, we can use the short form where we include this in front of the variables. And if they then correspond to the values that are available as attributes, they will be set at once. We can also create constructors with a name, like planet.createPlanet. This is still a constructor, but it is a named constructor, createPlanet, which is useful from time to time. We will see an example later on. And just as for the normal functions that we saw last time, constructors can also be made with this named way of doing it, namely to, in curly braces, set name and number of moons like this, and then we need to specify the name of the different parameters instead of the position of the parameters. Advanced features in object orientation is usually inheritance, abstract classes, interfaces, polymorphism, and so on. And they are also available in Dart. They work more or less like in other programming languages. And in addition to these normal things that we have, Dart also has mixins and extension methods, which we won't look into here, but could well be something to check up later on for you. Inheritance is that you could extend a class. So if we, for example, have a class fighter as here, and then we want to extend it with everything that's available in Starship, then we have an inheritance where we also say that a fighter is a starship. So the public parts are inherited down to the new class. In this case, the new class is fighter. And then we can add new things to this subclass. And we can then create objects of the subclass instead of doing it from the superclass, which is Starship in this case. As with Java and most other programming languages, we have a super class called object, which all the different classes inherit from. If we don't want to be able to create objects of a class, for example, if we have it in a hierarchy, that is a inheritance structure, then we can use abstract. So abstract class Starship, for example, means that we just put the stuff that we know that different kinds of starships will be using in one class, and then we inherit down to fighter and freighter and racing ship or whatever it might be from that class. An abstract class can contain both concrete methods and abstract methods. And if a method is abstract, we just end it with a semicolon, like we can see over here, int weight, for example. And that means that the subclass needs to implement it. And of course, it can have attributes and mutator methods, just as any other class. There's also something called interfaces, which is a kind of a contract where we only specify what methods should be available. No attributes, just the methods. Prior to .3, which was released in spring 2023, we didn't have a keyword interface. Sorry. Today, though, we have the interface. So that basically means that we can declare a class as an interface, and that means that it cannot contain any attributes, and it cannot contain any executable code. It can just have the signatures of the different methods, and then we implement it by using the keyword implements for a specific class. So class fighter, for example, implements hyperspaceable. And we can have many interfaces that we implement. So like in the last example here, we implement hyperspaceable and cloakable. But we can only inherit from one class. So we cannot use extend with more than one class. However, implementation with interfaces can be done from many of these interfaces. Not strictly object orientation, but closely related to it is this notion of generics, namely that we are able to create something like list, a data structure of some sort, and say that it should be general purpose. It should be possible to instantiate for a specific data type, but we do not want to declare the data type before we create the class. So if we want, for example, to create a class point, we could just add this less than, larger than, and then a T or an E or an F or whatever we like inside of the less than and larger than, and this will be a substitute for the real data type that we are going to use. So if we instantiate this as point int, like we do in the example at the end, this means that we will create a point which will only be using ints, and that means better type safety, and that's the main reason for why we should be using generics. And there are a lot of examples of this in Dart, for example, the list. But we'll see that a number of widgets are also using this kind of structure. So you need to know about it. In this course, you won't need to create your own generic classes, but as I said, it's good to know about it. Is there more on object orientation? Yes, loads, because this was really just a quick crash course. If you know of object orientation from before, well, then you can apply that knowledge to Dart and to Flutter itself without any real difficulty, I would say. If you don't, then you might need to read up a little bit through the links that we gave previously. However, you don't really need to know all the different parts of object orientation in order to use Flutter. You need to have this basic understanding of what it is and how it works. And it helps you a lot in understanding how Dart works and Flutter really works. But with that, we are actually done for this time. It was a short lecture and you might need to read up. But until the next time, have a nice day. Bye.